Let's go to page 540, and this is lesson 11-8. So this lesson is about to use the binomial theorem to find a particular term of the binomial expansion. So what you need to do is you need to use this formula right over here. So this is a formula. It looks really complicated, but once you know how to do it, it's very simple. So this is the binomial theorem. This is what you need to use. Okay. Now, binomial theorem is see what happens when you expand. Before you kind of use the Pascal's triangle. Now, Pascal's triangle is good when the exponent is kind of low. Okay, like when you're up to like 5th power or 4th power, it's faster if you use Pascal's triangle. But when you get a higher exponent, when the exponent is higher, and you don't want the whole thing, then it's better to use the binomial theorem. Okay. So the binomial theorem, the way it works is this, okay? So let's go to example 1. And I'm going to just do a modify, I'm going to change a little bit. So if you have a plus b to the 20th power, so over here they give you the first 4 terms, and you want to get to the next 2 terms, right? So it means you have the 6 terms. But I'm going to go over how you get the first 4 terms. So for every term, you're going to have 3 parts, okay? So what you do is, so we're going to just do the first 6 terms, okay? So again, every term has 3 parts. Okay, let's just do the first 4 terms before we do the next 2, okay? The next part is the first one goes in the beginning, actually, this goes in here. So you're going to get a and the 20th power. So you go to a to the 20, a to the 19, a to the 18, a to the 17. Right? So you start with highest and you go down. Now the b, you start with 0 and you go up. Okay, and this how to add up equal to 20. So this be 1, see that? So 20 plus 0 will give you 20, 19 plus 1 give you 20. So this be a 2, and this would be a 3. Okay? And that's going to do the next 2 also, okay? The one we're looking for. So again, every term has a 3 parts. I'm gonna, since I'm running out of, okay. So this would be a to the 16th, b to the 4, b to the a to the 15, b to the 5. Okay. And now, to figure out the first part, what you need to do is use the 20. So what happens if you have 20? So you're going to go 20 factorial. See, the 20 goes on top, okay? And whatever the number down here goes on the bottom. So it would be 20 factorial, 0 factorial, okay? This one would be 19 factorial, 1 factorial. This would be 20 factorial over 18 factorial, 2 factorial. This would be 20 factorial over 17 factorial, 3 factorial. See the 17, 3, it goes down here. So that's the binomial expansion theorem. Okay, so, okay, and this would be 20 factorial, 15 factorial, 5 factorial. Okay? Then your next step, make sure you don't skip the next step, okay? So what you want to do, you want to evaluate each individual part. This one, there's no coefficient in front, so you can skip this part. You can just go straight and figure it out, okay? But if there are more parts over here, as we're going to do like later, like example 3, okay? Then you will see that you have to do additional steps. Anyway, so you go and evaluate, okay? So this will give you 1 times a to the 20, and this would be 1, right? b to the 0 is 1. And this one would be, so again, so we want to simplify each parentheses, okay? And so this will give you 20, and this would be a to the 19 and b to the 1, okay? And the next one, okay, so this one, again, you can use calculator to figure it out, okay? So you can use or you can use the 20C2, okay? So this is same thing, 20C2. But anyway, so 20, 19, 10. So it'd be 190 times a to the 18 b to the square, okay, and plus, okay. So anyway, you get the idea, right? And so that's how you do each part, okay. And so this one you simplify. So you got 20. Let's see. Okay, so it'd be 1140. So number gets really big. Okay, b to the 3. Okay. Okay, let me double check. So 20 times 19 times 18, 3. Okay, yeah. Okay, so that's that. And then this one, you just plus. Okay. Okay, so you got 4845 and a to the 16, b to the 4, and then so you get 15504, a to the 17, b to the 3. Okay, so that's what you need. You vary each one, and after you simplify. Okay, so this is the binomial theorem. Okay, so let's go and do the example 3. So example 2 would be just exactly the same thing. Okay, you just do the first 5 terms. Okay, so example 3. It says find and simplify the 7th term. Okay. Okay, so another thing, notice that so this is the T1, this is T2, this is T3, this is T4, okay? And this is T5, this is T6. So one thing you notice that this is always 1 less than that. So when T1, for T1 you're going to get 0 power, T2 you're going to get 1 power, T3 you're going to get 2 power. So this, the last part, the exponent is always 1 less than the n. Okay, so this is n minus 1. So keep that in mind. Okay, so you're looking for the 7th term. Okay, so you're looking for T7. So you can remember every term there would be 3 parentheses, right? So this part goes in the front. Now this is where you have to be careful. Okay, so whatever is over here, you have to watch out for the sign so it's negative. Okay, so this one has 2 different things. For one thing, that's a coefficient over here, and this has negative in front. Okay, so now you're looking for T7. That means this would be a 6. Right? Remember, this is always 1 less than that. From our previous example, from the pattern, see that this is 1 less than that. This is 1 less than that. So for T7, this is 6 power. So if this is 6 power and the total is 10, so this would be a 4. Right? 6 plus 4 will give you 10. So once you figure this out, then you can figure out this part over here. So 10 factorial, right? 10 goes on here, the total goes on here, over, and this 2 number would be 4 factorial, 6 factorial. Okay? Then after that, so you can use your calculator. Okay, so this is same as 10C4 or 10C6, doesn't matter, they're the same, or you can use factorial. Okay? So I'm going to get 10 NCR. Again, you can use either 4 or 6, they are same, right? So 4 equal, so I get 210. Remember now, you have to simplify each parentheses before you put them together, right? So 2 to the 4th power would be 16, x to the 4 power, right? 2 to the 4 is 16, and x to the 4 is x. Now negative to the 6th power is positive, y to the 6 would be y6. So make sure you simplify each parentheses, okay? And then after that, you can put them all together. So T7 will equal to 210 times 16 equal to 3360, x to the 4, y to the 6. Okay, and that's your answer. So by doing this, you don't have to use the Pascal triangle and to do all these things. Okay? Okay. Okay, we have time, so let's go back to do example 2. You're looking for the first 5 terms in the expansion of, so you got a minus b to the 12th power. Okay, and you're gonna find the first 5 terms. So remember, every terms has 3 parentheses. Okay. I don't think I have time space over there, so I'm just gonna do it down here. So you just do the first 5 terms. Okay. So again, you're gonna start with a to the 12, negative b to the 0. Right. Remember so keep track of your negative. Whatever is over here, you put in here. Right. So you're going to get a to the 11, negative b to the 1. Again, all this have to add up equal to 12, right? So a to the 10, I'm putting in the wrong place. So a to the 10, negative b to the 2, a to the 9, negative b to the 3, a to the 8, negative b to the 4. Okay? The next step is how to figure your coefficient. So the total goes on top, and this goes on the bottom. And this one would be 12 factorial over 11 factorial, 1 factorial. This would be 12 factorial over 10 factorial, 2 factorial. Okay. And this would be 12 factorial, 9 factorial, 3 factorial. And this would be 12 factorial over 8 factorial, 4 factorial. Okay, now because there's a stuff inside, so you need to go and simplify every parentheses. So this will equal to 1, this will equal to a to the 12, and this will equal to 1. Okay, this will equal to 12, and this will equal to a to the 11, and this will equal to negative b. Okay, so keep track of your positive, negative. Okay, and the next one, this one would be, okay, so you got 12, NCR 2, so it'd be 66, a to the 10. Now negative b squared will give you positive b squared. Okay, so negative squared is positive, b squared is b squared. So make sure you simplify each parentheses. Okay, and this one would be 12 NCR 3, so it'd be 220. Okay, this one NCR 4 would be 495, and this would be a to the 10. A to the 8. Yeah, so be careful. Make sure you watch out for careless mistakes, and this would be positive b to the 4. Okay, so you can simplify every parentheses. Okay, then you multiply this together. Okay, so this one doesn't have a number in front, so it's not too bad. So you're going to get a to the 12, and this one would be minus 12a to the 11. Notice when there's a minus, the sign is going to be go plus, minus, plus, minus. Okay, always. Okay, so 66, a to the 10, b squared, so plus, minus, plus. Again, next one would be minus. Okay, minus 220, a to the 9, b to the 3. Right, put a negative to the front, plus 495, a to the 8, b to the 4. Okay, so that's your first 5 terms. So this is a binomial theorem. So that's how you expand or to look for any particular term. So again, that's what the formula is. Again, the formula looks very complicated, but once you know the steps, it's very simple. Okay. So again, you start with the highest number, right? So 12, 11, 10, 9, 8. The second part, you start with 0 and you go up. So one start from the max and you go down. The other one will start with the minimum and you go up. So 0, 1, 2, 3, 4. And this how to add up equal to total, right? 11 plus 1 give you 10, 12, right? So again, this how to add up equal to total. Okay, once you figure out this exponent, right? Then the factorial would be the total goes on the top. See that 12, 12, 12, 12, 12, right? The bottom would be these two numbers, so 12, 0, 11, 1, right? 10.2 goes on here, 9.3 goes down here, 8.4 goes down here. Then after that, okay, take your time, okay, evaluate every single parentheses, then you put them together, and that's how you expand. Okay. So this saves you a lot of time rather than write it out, like 12 times and you multiply using the FOIL method. It's gonna take much longer.